and please take it away. This is the final segment of this episode, and yeah,
Awesome. Thank you for having
uh,
us on and appreciate the Lido community for listening in today. Some cool presentations before us, but here to talk about Commit Boost. Some of you may have heard about it or saw some posts on Lido. I'll show a bit on the agenda we'll go through. And here's the QR link to our first post to the Lido community. We'll talk a bit about what Commit Boost and generally there's trends that are unlocking across the staking community, some challenges in the direction we're potentially headed. And then this is where Commit Boost comes in and why it was really created. Tell you a little bit more about how it works, some milestones we've hit in timeline, and then ways to get involved, sort of call to action. So with that, there's this general trend within the research community, and this is some quotes from some EF researchers across RIG and of course Vitalik that have talked about today you have this mechanism where proposers, it's their turn to build a block, but and they have a monopoly over that, but what they end up doing is outsourcing that and they lose quite a bit of the autonomy over that. And these are a couple quotes from research where it talks about what if the proposers could give templates or make more specifications around how the block must be constructed. And I think Vitalik says it best, as usual, where he says, what if we could make, for instance, 80% of the block be about an inclusion list? And you could think of that inclusion list in a lot of different ways, but essentially expressing the ethos of that next proposer. And then it would force the downstream participants in the PBS pipeline, such as the relay and builder, to abide by those rules. And I would say about a year ago or earlier this year, people started to realize this. And there's been a bunch of teams building towards this vision, the infrastructure and everything that's required. But this digs deeply into past commentary, including Pepsi, which came out of the REG group with Barnaby. Um, but with all this is probably, I'd say, 5 to 10 teams building around this. The challenge is a lot of them, the way they were going about this was to create a fork of MetBoost, for instance, or a new sidecar. And uh, in the future, proposers are going to face a lot more decisions around what they quote unquote commit to. Today, it's just a block header, but it's likely to be more things. And this can come through. And I think the community's heard about things like pre-confirmations, but this could be inclusion lists. It could be block space futures, top-up block auctions. There's a whole host of ideas. But when this is implemented via forks and different implementations of sidecars, there's a couple of risks that we started to see play out. Fragmentation is number one, and this impacts validators, but also the Ethereum network. For sophisticated stakers, they probably can run multiple sidecars, but don't want to, at least the ones we've spoken to or prefer not to. And for home stakers or solo validators, this becomes quite difficult. We just saw a great presentation where a lot of these tools are streamlined, but having a home staker have to choose, I want to run 5 sidecars, what all that even means is tough to navigate. So that's the number one risk we saw. And then second is developer complexity. So when there are hard forks and upgrades in Ethereum, the challenge is that even with just MEV Boost, it always is one of the things we have to think about. But if we had 10 MEV boosts, 5 MEV boosts flying around, or different versions of that, it'd be an additional load on those teams who are already carrying a lot for us. The last is some of these sidecars, they are VC backed. Almost all of them are open source, so it's less about that. But Flashbots has done a fantastic job historically around MetBoost and just keeping it really as a public good. They don't monetize it, and the ethos of that is something I personally really strongly believe in, and Commit Boost is about. And so what we want to do is have a solution or option out there that helps to solve these things. Is a public good. We don't plan to monetize. There's a 501(c)(3), and I'll get into that in a moment. But this is sort of why Commit Boost was created. And so we have this vision in the future where we give proposers back autonomy to trust the million-plus validators that are out there to express the ethos of Ethereum. And then there's these risks that are starting to emerge that we're hoping to mitigate. So what is Commit Boost? I'll start with a qualitative sort of discussion around not only the software, but just generally this community that we're helping to shepherd. And Then we'll get into the technical details in the next slide. But Commit Boost, its mission is it's a not-for-profit. It's a 501c3, fully grant-backed. There's no token, no monetization, and the sole focus is education around open source software, but also development and sustainment of Commit Boost, the software. And the idea here is to have a 24/7 team, follow the sun model that is helping to support this software. The product itself is it is a new sidecar, but it's one sidecar that validators can run and still get access to all the commitments that we've talked about previously. And so the idea is let's just standardize the last mile communication between the proposers and these commitments or proposer commitment protocols. And that's where Commit Boost sits. And so they can run one sidecar, they can opt into PBS, they can opt into inclusion lists, they can opt into pre-confirmations, they can opt into pre-confirmation for one team, then easily switch to the next just by opting out of one module and opting into another. And so that's where we're focused. And what it comes down to is standardizing how really a signature is provided by the validator. A majority, next is increased safety. A majority of the Commit Boost code is actually around safety. It isn't so much the standardization. And what I mean by this is we've attached extensions, things like monitoring tools, safety checks, additional fallbacks, proactive OPSEC risk mitigation tools to help validators as they're making commitments to have all these tools in their hands to mitigate risk tied to this, so that the Ethereum network isn't at risk at a validator missing a slot, and it continues to be robust. And this includes things like even just running the PBS module on Commit Boost, you get out of the box 25 plus metrics and transparency across the transaction supply chain that's automatically uploaded into Grafana. So it's just things like that that we have built into this. I touched on this, but neutrality. The Commit Boost is just standardizing the last mile communication. It's not it's restaking agnostic, it's pre-conf agnostic, it's a proposer commitment agnostic. It really doesn't limit anything downstream. And so if you were a validator and you wanted to build a block only through Suave, you could, for instance, specify that as, hey, the transactions must be packed, or the block must be packed via those TEs and those builders. Security-wise, it is open source, it is community reviewed. We talk about this next sort of bullet, but there are now 70 plus teams that are helping with this. Has a broad set of validators who've done this for a very long time, not only contributing code, but contributing ideas. And then we are getting it audited, and we're moving into that actually this week with a code freeze. I touched on this, and there'll be more about this tomorrow as we announce moving towards mainnet, but 70 plus teams that are helping with this. It started with just a few, and I'll turn it over to Kubi right here. Just a few, and Kubi was one of the early participants of this who helped us envision this and build it. But now we have a ton of teams across the whole ecosystem, spanning client teams, validators, restaking, L2s, researchers. I'm sure I'm forgetting some, but why don't I pass it over to you, Kubi, to talk a bit about the technical architecture.
Yep, sounds good. Hey everyone, Kubi here. Good to be back on a community call. I'm just gonna go into the high-level architecture of Commit Boost and also just go a little bit into some of the motivations that are behind some of the technical design choices. And so as Drew said, the context here really is, so what we're thinking about, how do we avoid having to run like all these different sidecars, and how can we basically encapsulate some of the logic that these separate instances will facilitate. And that's basically like some form of communication to interact with the proposer commitment protocol. And then have that compartmentalized in a way where the logic is separated out, but you have a unified sort of platform underneath that can instantiate or access to this different proposer commitment protocols. And so the solution that we basically came up with is, first of all, having this notion of like this base platform, which has like this launcher component. And the launcher is basically responsible for then instantiating like multiple instances or potentially just single instances of how to tap into a proposer commitment protocol. And that is via instantiating a module. And here we basically just leverage existing containerization technology to just be able to put certain safeguards into place around operational security, as Drew said. So these are just simple things around making sure resource consumptions around like CPU usage, disk, and memory and things like that can be controlled by node operators, so as just to give them more security around the different modules that they can actually run, and also limit the risk of it taking the potentially entire box down. But then additionally, commit boost also provides just a bunch of primitives out of the box to the module creators and gives them standardized interfaces. So what does that mean? So one of the things that's very important for node operator is just analytics and monitoring. So for example, we provide a bunch of primitives so that it's very easy for module creators to create like metrics, and then we have like a really nice way to then, for example, to tap into Prometheus and Grafana, which are like just standard tools that are just being used across the board, to then basically keep on top of what these modules are doing in real time. And not just, this is not just about resource usage or what these modules are doing on the box itself, but also how they're interacting with the external protocol. So for example, this would be within the context of commit boost, or specifically if you think about PBS and the MEF boost protocol, this could be, for example, what kind of relays is your module talking to, what are the response rates and things like that. The other thing is that essentially what a proposer commitment is the request for the proposer to commit to something. So in the context of PBS or MEF boost, this would be a proposer committing to a header based on certain kinds of rules. But there are other things that the proposer can commit to. For example, in the context of pre-confirmations, you might want to make sure that like certain transactions are included in a block. So you might want to verify that there are certain things are included before committing to a header. And there's additional logic that these modules can basically run. And so another thing that we basically provide is like the standardized interface of requesting a signature. And here we placed a lot of efforts, and some of the research is still ongoing, to making sure that this can be done in a safe way. So for example, what we really wanted to avoid is like having these modules requesting signature from the consensus keys directly, and like potentially just exposing risk that the validators could be slashed in protocol, for example. And so like some of the things that we've done is just the enablement of proxy keys, using different signing domains, and just a bunch of other stuff just to make sure that none such potential malicious signature requests can be done by these third-party modules. And then the last thing I just want to cover on a high level is that from day one, a lot of effort is being made to make sure that this entire thing is backwards compatible. So just think about, again, PBS and MEF boost. For example, no CL changes are required, and we just tap into the existing Builder API, and no changes are required whatsoever. And then for new types of commitments that are being made, initially these signatures, again, through proxy keys and certain safeguards, will be enabled through tapping into existing key management software that node operators are already running. So examples here are Web3 Signer and Dirk, but we're also speaking to DBT and also to validators or node operators that use a more monolithic setup. For example, if they use the consensus client keys directly in the VC. So some of these items still need to be ironed out, but overall, the goal is basically to abstract all of that away from the module creators. We create like one safe standardized interface for these signatures to be requested, and then basically do all the heavy lifting in the background, and the engagement again with community and the different tools that are being used by node operators to enable this. Yes, and this basically wraps up the architecture overview.
Awesome. Thanks, Kubi. Well, I know we're close to time, but just quickly go through some milestones. We've had Kubi touched on the shipping side, but just some things to highlight. A lot of the research we've done is just engaging with a lot of validators. They have a bunch of different setups, and we're just trying to configure as much as possible to give the whole network of Ethereum the ability to run commit boost. Like Kubi mentioned, it's PBS compatible with a whole host of extensions. We're already testing in Husky with hundreds of thousands of validators. I'll provide the link in the next slide, but we also posted on Lido through, I think it's called the Perch, maybe butchering the name of this, but a way to engage with Lido node operators. So we've asked for feedback and more teams to engage there. Then, as Kubi mentioned, we're just working with all the ways that you could be able to sign on things outside of just a header, which is done through PBS. Community-wise, mentioned this 70 plus teams, 12 direct contributors. There's 5 plus modules that are already being built on Commit Boost across pre-comps, inclusion list, and a few other things. We do have community calls going. This is an open source public good, so we hope it's driven by those that are using it, part of the community that's being led by Alex Stokes. Yeah, we've set up a 501c3 or setting one up with multiple grants, including a request to the Lido community, which I think was approved, or at least details published on the post today, which we're super excited about. But there's other organizations that have provided funding as well. And then we also, just to help the community push along in this journey, is helps pay for and host Helder, which a bunch of teams are using. And this is mainly a persistent testnet to quickly iterate on proposer commitments. And then the last slide is just, or next last slide is just timeline. This is our progress and all those milestones that have been hit. We're now going into audit, so we expect Commit Boost to be in mainnet within the next month, and we're super excited about that. And then just increase adoption throughout the end of the year and into next year. If you want to get involved, here's a couple QR codes. One is our repo. You can learn more there, submit PRs, provide feedback. The other is the post I mentioned on the Lido forum, research forum. Please fill out, reach out, whatever we can do to get you working with us and getting feedback. So with that, I think that's all we have.
Awesome. Thanks, Drew. That was really cool. A question I have, like overall, this is putting like more power into the hands of the validators, in essence. I think we've learned from Spider-Man that with power comes responsibility. I think MEV Boost introduced responsibilities for node operators that we didn't really have before. We're talking about censorship now and choosing which relays to choose, besides latency and technical issues like that. So where do you think this is going from the node operator perspective? This is our target audience of the call after all. So what are responsibilities and tasks are they going to get with this movement in general?
Yeah, there's, I think one of our community members wrote a great quote on one of the slides we use, but it's kind of like they're going to have more decisions to make over, other than just a local payload or a payload built by a builder, if they choose to. They can still have that, but they're likely going to be missing out on rewards related to things like pre-comps. How I personally expect this to play out is there'll probably be a few of these proposer commitments that accrue value, or at least provide value to the end users of Ethereum, whether that's L2s or users themselves, that will pay for these services from validators. And so I expect some culmination around 4 or 5 of these over time. I don't expect personally there to be 100 plus of these commitments flying around in the network. And I think the benefit of this is that today, as a block is constructed, proposers sort of turn over all that autonomy to 3, 4 relays and 2.5 builders, given the current metrics. And at least in this instance, we now allow for at least 1 million plus Ethereum validators to express the ethos of Ethereum, or at least have the opportunity to do that and be able to run an inclusion list module and say, do not censor my block. It's quite a powerful future I see progressing here.
Yeah, cool.
With that said, yeah, there are risks, right? With this, you give autonomy, power to people. There are risks of that, and we're speaking with some of the teams that are out there that are assessing risk, like Rated, a few others, to help get their hands around this. And in the future, when these commitments are ready, they're there to help guide validators just as they do today across a whole host of things.